Hello everyone, I'm Kezang and I'm excited to welcome you to my video presentation on single phase induction motor. I will be explaining the construction and double revolving field theory. A single phase induction motor is a small size motor with a fractional kilowatt rating. They work on a principle of electromagnetic induction to create a rotating magnetic field. Why single phase AC motors are required? Because most of the domestic loads are low rated and work on single phase AC supply, and single phase DC motor will need separate conversion systems. Thus, single phase AC motors are required for domestic purposes like in hair dryer, small toys, fans, grinders, and etc. Now the construction of single phase induction motor. Similar to the three phase induction motor, single phase induction motor also has two main parts. One rotating and other one is stationary. The stationary is called stator while the rotating part is called rotor. Stator. The stator has laminated construction made up of stampings. These stampings are slotted on its periphery to carry the winding called stator winding or main winding. The stator core is laminated to reduce the eddy current loss. The single phase supply is given to the stator winding. The stator winding is wound for certain definite number of poles. So the number of poles for which stator winding is wound decides the synchronous speed of the motor. Now rotor. Rotor of single phase induction motor is same as a rotor of squirrel cage induction motor. Instead of rotor winding, rotor bars are used and it is short circuited at the end by end rings. Hence, it makes a complete path in the rotor circuit. The rotor bars are braced to the end rings to increase the mechanical strength of the motor. The rotor slots are skewed at some angle to avoid magnetic coupling, and it also used to make a motor run smooth and quiet. Now to move on with double revolving field theory. This theory is based upon alternating uniaxial component represented by two oppositely rotating vectors of half a magnitude. Accordingly, the revolving flux in single phase induction motor can be represented by two revolving flux, each equal to half the magnitude of alternating flux rotating in same synchronous speed in opposite direction. Let phi m be maximum alternating flux. Its component flux A and B will be phi m divided by 2 rotating in opposite direction, as you can see in the every figure that is given below. So the figure A is when the phi m is maximum. Figure B is when phi m is phi m cos theta, and figure C when phi m is 0, figure D when phi m is negative phi m, and figure E is when phi m is 0. The torque produced by clockwise direction flux and torque produced by anticlockwise flux will nullify, and net torque is zero. Hence, a single phase induction motor can't start by itself, so it's non-self starting machine. So if there is initial torque, we can derive the torque speed characteristics. You can see the figure that uh, the torque produced by the clockwise direction and the anti-clockwise direction flux is resulting in the zero net torque. So in practical field, it is not possible to give initial torque. Hence, some modifications are required to make induction motor to start by itself or self-starting. Thank you.